This is the Math 3 Unit 2 Whiteboard Review, Part 1. Number 1, we have a function and we are asked to state the intervals. We're actually going to write open intervals. For increasing, decreasing, and constant, so those places on this function. So the increasing places on my function, I have 3 portions of my function that are increasing. So I want 3 intervals, and each interval needs to be connected by a union. So my first increasing domain, which is my x values, I need to start at my lowest x value. Well, this piece has come somewhere from the left-hand side because this goes forever to the left. I could keep writing this out. We don't know where this begins, so it means my x values go all the way to negative infinity. And this will be increasing from negative infinity all the way to the x value of negative 4. So this is my first x value I need to stop at. So from negative infinity to negative 4. Then we go to decreasing, then constant. My next increasing interval is from the x values of 0 to positive 2. You're only filling in x values down here. So from 0 to 2 for my x values, I am increasing. And then again from 5, and we don't know where this stops, so this goes on forever, from 5 to the x value, forever to the right, so 5 to infinity. Excuse me. And that's our increasing answer for each of our intervals. My decreasing solutions will go from, we'll have 2 intervals for decreasing. My first one starts at the x value of negative 4 and stops at the x value of negative 3. My next one starts at the x value of 2 and ends at the x value of 5. So from negative 4 to negative 3 and from 2 to 5. My constant, I only have one piece of my function that is constant. That starts at the x value of negative 3 and goes until my x is equal to 0. So from negative 3 to 0, we have a constant interval. On the back side, we're going to use the same graph. I'm going to show another one so that we can look at the question and the graph at the same time. So flipping to the other side. Question number 1, parts B through G. The lettering's a little off from the front page, but that's okay. Starting with our first true and false statement, using the same graph from number 1, does f of x equals 0 have 2 solutions? Well, I know that this means my y value is equal to 0 because f of x is talking about a y value. The y values that are equal to 0 are at negative 6, 0, and 5, 0. We also call those x-intercepts. Whenever your y value is at 0, we're going to cross the x-axis. And I do have 2 places where we cross the x-axis, so that is true. To help you with the rest of the problems on this page, I'm going to rewrite this as a correct statement using this f of x, meaning I'm going to plug in an x value that gives me an output of 0. So using each of these points, if my x value is negative 6, I get an output of 0. Also, if my x value is 5, I get an output of 0. So these are just some examples of how you can write an input-output from a point. So my x value is the input, so I plug that in for x. My y value is the output, so that's what my answer will be equal to. which helps me on this next one. So essentially, f of 0 equals -6 means the point 0, -6 is on this function. And that is false because 0, -6 is down here. And that point is not on the function. So that means f of 0 actually equals whatever the y value is when your x value is 0. And that's 1. So f of 0 should equal 1, not -6, so that one's false. So we know this point is not on the graph. The correct point on the graph would be the point 0, 1. All right. F of -2.7893. That means my x value is -2.7893. My output is 1, so that means my y value is 1. So I go to -2.7893. That's somewhere between -2 and -3. And my y value is going to be, well, since this is on a constant, I know my y value is 1, which makes this solution true. Because all of the y values on that constant line are 1. E and F are both talking about relative minimums. So my relative minimum is when I'm changing from decreasing to increasing. And it's the point at which we change. Has to be changing from decreasing to increasing. So part E, at -3 for my x value, that's this point right here. I want to know, is that a relative minimum? Are we changing from decreasing to increasing? No, we're changing from decreasing to constant, so that is false. At my x value of +5, are we changing from decreasing to increasing? Yes, so that is true. Part G, f of 2 is less than 0. That means when my x value is equal to 2, is my output less than 0, or is my y value less than 0? Let's look at our x value of 2. So on our function, if I go over 2, my plotted point is 2, 2. So 2, 2 is the one I'm looking at. If my x is 2, my y value, well, this +2 is not less than 0, so that's false. You could also look at that as a height. That's saying when x is 2, is your height less than 0, meaning below the x-axis, and that is false. Question 2. If a is less than 0, or in other words, a negative number, state the solution. So all of these values have a values that are negative numbers. We want to know if our solution is no solution or all real numbers, meaning every solution works for x. So let's think about this. This means you're taking the absolute value of a number. When I take the absolute value of a number, I should get a positive answer. My sign is less than or equal to, and we know the a value, we want it to be a negative number. And that's going to be the same for all of these. Absolute value is going to give you a positive number. The a value in this case is a negative number. And we want to see which of these statements is always true or never true. Those are the only options we can have because always true means all real numbers. Never true means no solution. Can a positive be less than a negative? No, can't be less than or equal to a negative because it also cannot be equal to a negative. So this is no solution. Can a positive be greater than a negative? Yes, it's always greater than a negative, so this solution is all real numbers. Can a positive be equal to a negative? No, never, so that is no solution. Number 3, solve for x. the absolute value of 2x minus 7 is equal to 15. What that means is this expression inside could equal positive 15, because if you take the absolute value of 15, you get 15. The other option is this inside could equal a negative 15. So the absolute value of negative 15 equals 15 as well. So we split this into two equations because we know that expression could equal positive 15 or negative 15. So I'd split it into positive 15 and negative 15. But the 2x minus 7 needs to stay exactly the same because that's the expression inside our absolute value. So then I add 7 to each side, and 15 plus 7 gives me 22. And then I divide by 2 on each side, and 22 divided by 2 is 11. I'm going to do the same thing over here, adding 7 and then dividing by 2. Negative 15 plus 7. A negative plus a smaller number is going to leave me with a negative. The difference between 15 and 7 is 8. So negative 15 plus 7 is going to give me negative 8. And then I'm going to divide each of those by 2. Negative 8 divided by 2 is negative 4. So my two solutions are x equals 11 and x equals negative 4. You could also write them in set notation if you wanted to. That means the two solutions are the two numbers that are listed inside this set, negative 4 and 11. Number 4. Whenever I have an absolute value is equal to, greater than, less than, anything with a negative number, I need to check to see if this is a special case. So first I isolate my absolute value. Good, it's isolated. I should have checked this on number 3. Is this a special case? No. This number right here would have to be negative in order for me to have a special case, just like what I did on number 2. These were all negative numbers, which were telling me the special cases. But on number 4, this is a negative number after my absolute value is isolated, so this is a special case. You can look back at number 2 to help you decide this, but let's talk about what type of number you would get from an absolute value. When you take an absolute value, you always get a positive number. So this statement says a positive is less than or equal to negative 12. When is a positive less than negative? Never. So this is no solution. Number 5. Is the point a solution to the graph? So this is a shaded region all under your absolute value function that's been graphed. So anything in the shaded region is a solution to the graph. So we're going to find all of the points that are listed on A through D. Starting with 2, 3. Over 2 up 3 is right here, which means no, that is not a solution because it's not in the shaded region. 3, negative 1 is right here, which means yes, that is a solution because it is in the shaded region. 5, 1, that is not in the shaded region, so no, that is not a solution. And 0, negative 2. Yes, that is in the shaded region, so yes, that is a solution. Number 6. Solve for x. I have a term squared, which means I can solve by using square roots. So if I have a and a b value, meaning x squared and an x term, I can't solve by using square roots. But this one, I just have a term squared, so I can. So I'm going to start by adding 5 to each side. And then I want to get rid of the square root. I'm sorry, I need to get rid of the square so I can take the square root in order to get rid of that. Don't forget, when you take a square root, that gives you a positive and negative solution. Because if I take the square root of 16 to get 4, I also know that negative 4 squared gives me 16. So let's see, I get plus or minus 4. And then the square root cancels out the square, so I'm left with x minus 3. At this point, you can separate it into two equations. I get x minus 3 equals positive 4, and x minus 3 equals negative 4. And then we solve. So we add 3 to each side, add 3 to negative 4. Negative 4 plus 3 is negative 1. So my two solutions are negative 1 and positive 7. Number 7. If f of x equals x squared plus 9x and g of x equals 5x plus 32, solve f of x equals g of x. So our first step is to set these two expressions equal to each other. In order to solve a quadratic, I need to either be able to solve by square roots or to have my standard form equal to 0. I can't solve by square roots when I have both an a and a b term. So I'm going to make everything equal to 0 by subtracting the 5x to the other side. And then I'm also going to subtract 32 to the other side. You can do those all at one step if you would like. If it's factorable, I think it's faster to factor. So I'm going to multiply x squared times negative 32 to get negative 32x squared, and determine what terms multiply to get that and add to get 4x, which is 8x and 4x. One of these needs to be negative in order to get a negative 32. I know that 4 minus 8 is negative 4, so that doesn't work. 8 minus 4 would be positive 4. So I want a positive 8 and a negative 4. I'm going to rewrite my middle term. When I rewrite my middle term as two separate terms, I can start to factor by grouping. You could factor using the short method here, and you'll get to the same answer, but I'm going to go ahead and take out a greatest common factor from each set, meaning if I split this down the middle, my greatest common factor on the left is x, so I'm left with x plus 8. My greatest common factor on the right is negative 4, so I'm left with x plus 8. Now my greatest common factor is x plus 8, so I'm left with x minus 4. And I need to solve. Solving means, what does x equal? This is factored but not solved. If I'm multiplying two binomials together to equal 0, that means I set each of them equal to 0 and solve, because 0 times anything will give you 0. Subtract 8 to the other side, add 4 to the other side, and you get the two solutions, x equals negative 8 and positive 4. You can write them as a set, or you can leave them separate. Either way is fine. Number 8. F of x equals x squared and g of x equals x plus 2. So we're going to solve 2 times f of g of x minus 23 equals 127. So I'm going to replace this with f of g of x and then that means you're going to take g and plug it in for f. So we're going to take the g expression, plug it into the x right in the f expression. The 2 is still multiplied out to the front. X plus 2 is going inside here, so I'm going to put it in parentheses. That quantity is squared, because my x is squared, minus 23 equals 127. So all I did was plug in the x plus 2 where the x used to be, and I put it in the parentheses. So in order to solve this, I can solve this by square roots because I have a quantity squared. This is a quantity squared. I'm going to add 23 to each side. 127 plus 23 is 150. 23 minus 23 is 0. I'm sorry, negative 23 plus 23 is also 0. Now I need to get rid of my multiplication by dividing. Now I need to get rid of my square by taking the square root, which means I take plus or minus the square root of each side. Don't forget the plus or minus. I'm going to simplify this radical on the right-hand side so we don't forget what it looks like. We're going to do 25 times 3 and then 5 times 5. Because it's a square root, I need 2 of each number, so that means the 3 is going to stay on the inside. We're going to keep the plus or minus out in front. The 5 goes out to the front. And the 3 stays on the inside because it doesn't have a pair. At this point, I need to solve for x by subtracting 2 from each side. The negative 2 and the 5 are not like terms because the 5 has a square root 3. So don't use them as combining like terms. You're going to leave the negative 2 out in front, plus or minus 5 root 3. And then number 9 is our last problem on part 1. So we're going to solve for x. And I know that this is quadratic because I have an x squared. I know that I won't be able to solve by square roots because I have an x squared and an x to the first power. So I must set this equal to 0. I like to keep my x squared term positive, so I'm going to subtract 6x to the right and add 7 to the right. This is 0, this is 0, so I have 0 equals 2x squared minus 6x plus 7. If you subtracted the 2x squared to the other side, you'll get the same answer, but you'll be having to reduce some negatives at the end of your problem. So we'll see what that looks like in a minute. So first of all, can I factor this? If I multiply these together, a times c gives me 14x squared. My b term is negative 6x. My factors of 14 are 1 and 14, 2 and 7. None of those are 6 apart, so I cannot factor this. This is not going to work. So instead, I use the quadratic formula. There's a song posted on Google Classroom. There is a little word trick posted on Google Classroom. So you can do the Pop Goes the Weasel song. It's negative x equals... I'm not going to sing it. I thought about it, but I'm not going to sing it. But let's do the word trick because that one was a good one. So you need to remember the x equals part, but it's the negative boy couldn't decide whether or not, so that's the plus or minus, to go to the radical party, so that's the radical. The boy decided to be squared, so he missed out on 4 awesome chicks. The party was all over at 2 a.m. That's a good way to remember it. You can do the Pop Goes the Weasel song. You can just memorize it. But you need to know the quadratic formula in order to solve this problem. So negative b is a negative negative 6 plus or minus the square root of b squared, so negative 6 squared, minus 4 times a times c. A is 2, c is 7, all over 2 times a. A is 2. So just a reminder, my a value is always in front of x squared, so a is 2. B is in front of x, so that's negative 6, and c is equal to 7. Those are the numbers I used to plug in to the parentheses. Simplifying, a negative 6 is just a positive 6. I'm going to simplify my squared term. Negative 6 is 36. Negative 6 squared is 36. And then I'm also going to simplify the right-hand side. 4 times 2 is 8. 8 times 7 is 56. So I have a minus 56. I only have one negative sign. None of my A or C values were negative, so it didn't change my sign. And then 2 times 2 is 4. At this point, we're going to simplify under my radical. 36 minus 56 is negative 20. If you get a negative under your square root, that means our answer is an imaginary number. So I get 6 plus or minus I square root 20 all over 4. But that radical is not simplified yet. You still need to simplify more. So if I simplify the radical of 20, I get 4 times 5 and 2 times 2, which means I can take out a pair of 2's and a 5 is left inside. Taking the 2 out to the front, I want to put it in front of my I in order to be in standard form for complex numbers. The 5 is left inside, and this is all over 4. This is all, each of these terms is divisible by 2, so I'm going to divide all 3 terms by 2. My final answer is 3 plus or minus 1 times I is I, root 5 all over 2. And that's the end of part 1 of the whiteboard review.